Hey guys, Blair from Automotive Supplies Group. Today I'm going to show you our latest purchase, which is a Autodiger AD500 alternator and starter motor test bench. All our remanufactured units will be fitted to this machine and tested 100% to conformity. All our brand new units that we already sell are already tested by our suppliers, but we'll be running them through this test bench as well, so we've got confidence in them when we send them out to you. I will just flip the camera around and we will check out this machine. So here we have it, the AD500 from Autodiger in Poland. There's our battery connections there, which are the leads which go to the alternator case and the power feed, used on the starter motor as well. The big emergency stop button for if anything sort of turns pear-shaped. This is the screen here, which has a interface to show us what's been happening, current versus voltage, and a couple of other tests there which show up red or green depending on if it's a pass or a fail. So the last alternator that I did actually was a pass. Down here is where we connect into the alternator for various different things. We have a battery feed, a W, which is for your wave, your phase terminal, your DFM, which is your feedback terminal. This is a percentage of how hard the alternator is working to achieve the voltage. Your COM terminal, which we'll be using for COM and LIN BSS systems, but this is also the terminal you use if you're doing an RVC GM or an SIG Ford system, and your traditional lamp there as well. Has a hatch here. Put the hatch down and you can use the machine. If the hatch is up, you can't use the machine, just for safety. Has a mounting system here, a couple of different adapters. This stuff all slides, adjusts, screws down, so it's very much a multi-fit. So there hasn't been anything that I haven't been able to put in here, or that I've struggled to put in here. It's all been fairly straightforward. Here is the belt. And the belt is wrapped around the motor at this moment. The motor actually has an automatic adjuster, so all you have to do is slip the belt on the alternator and push the button, which is here, and it auto tensions the belt. What I'm going to do is I'm going to get an alternator into the test bench, and once I've done that, I'll start back up again and come back to you. Hey guys, we're back. As you can see, I've got the alternator mounted in there. It's like a clamp style system. A couple of rods in here to help hold that all together. Some adjustment rods there. Then we've got the thread there which clamps it down, and then the thread on the top there which you can tighten up the alternator. The next thing is the belt tensioner, which I'll just tension up now so you guys can see that in operation. And it automatically tensions the belt for us. That's handy. We're going to be testing an alternator today, which is off a Land Rover. So it's the Ford SIG system, 3-pin plug there. We've got this alternator to check. It's an aftermarket alternator already that's been fitted to a Land Rover. It's been on the vehicle for approximately 8 months, I think. Customer has been having issues with it, and the original person to fit it is denying any sort of warranty on it. So we're actually getting it in to do basically a test on it, confirm that it is actually faulty, and the customer, the owner of the vehicle, can fight it out with the supplier of the product, which wasn't us, it's one of our competitors. Generally they're pretty good, so not sure what's going on there. Anyway, not for us to say. We'll plug the alternator in, 3 wires for the Ford system, which is your battery feed, your feedback, and your command signal. Connected into the machine here. I'll select the alternator. What we're going to do is an auto test. We're just going to do a standard test for now in this video, because I just want to see what this alternator does under a standard test. Reference: this alternator doesn't have an OEM part number, but I've managed to cross over the supplier's part number to something that's pretty close. The only difference is the supplier's one doesn't have a clutch pulley, but the part number that I've got here is an alternator that does have a clutch pulley. However, the alternator pulley diameter is identical, so I don't think this is going to be a problem. And that's the alternator number we've used. Okay, so we're testing 12 volt. It's going to be a current limit of 150, which is what these Land Rover alternators are. Rotation is clockwise. The interface system is SIG, which is your Ford system. Pulley diameter of 57 mil. Description. We can put in here any description, and let's just do. We'll just do Land Rover. Yeah, we'll just do Land Rover alternator, or Land Rover. Okay, this is our connection system, LIRCBVS. This is the same system that the Americans use. The terminal designations are called something different. Between the European Fords, the Australian Fords, American Fords, and Land Rover and Volvo, they can be called something different, but the pin placement, those terminals all do the same thing throughout all of those different systems. Well, when I say different systems, the different names that the different manufacturers give them. Right, so we'll just hook up the power feeds in the ground onto the alternator. We're just going to get a good connection here. Okay, so we've got the alternator connected up here with our power feed and our ground onto the body. What we're going to do is we will do a leakage test. This will just check the static current draw of the diodes, just in case there's any of them out. Hoping it should be 0. That's it. Right, now we can start the test. First of all, we're just going to close the hatch, lock it up. Belt's tight, and here we go. We're going to start this test. So the machine's going to connect the voltage up. Clicks away, 12.4. It's going to start rotating. DFM terminals at 94%, which means it's working really hard already because of the slow RPM. As the RPM increases, it comes down, whilst there's little current load. Well, we certainly didn't get the 150, I don't believe. I don't think I saw that 150. And as soon as any sort of decent load, 130 or more, came on, the voltage just dropped away, as you can see there with our graph. So I'm expecting this to be a fail. Yep, and it was. And that's a failed test. So we can print that up the top there. We can go through the setup, stuff that we did before. Time on this machine's out because it's not 7:30 at night. It's probably only about 3:30 in the afternoon. I'll have to set that up. And click on to other. Bits of information there. Any warnings? No. The alternator ripple. Pretty good. So what's our issue? Well, we'll have to do some further testing on the alternator to confirm that, but that's really not what we're doing. That was for our client to go back to the supplier and say, just don't think that this is working correctly. So there you have it. Here's our 8500. Here's the printout sheet. It gives you all the information. Result: failed. It was no good. That's the 8500. Thanks for watching.